Hello, everyone, and welcome to today's meetup. The team at ecosystem.Ai and our partners for the past few weeks have been exploring AI in financial services. And we've covered topics from implementation challenges to building versus buying AI capabilities and all the way to customer-facing products and services and how AI is reshaping things like loyalty and rewards programs. So today, we thought we would look at a different industry where AI and intelligent recommendations have transformed personalization and see how that can be applied to the banking industry. Hence, Bodhi and I today are going to be looking at Spotify and their recommendation systems and how they create a really hyper-personalized product and service and see how that can be applied to banking through a spend personality lens. So Bodhi is going to take us through some of the technical details, and together we're also going to look at the kind of business impact of their hyper-personalization. The session is being recorded and the recording is available on our YouTube every Friday. Just for a bit of context, Spotify is a music streaming service known for their personalization. They make really great new music recommendations to their customers, and they've cultivated this brand identity on knowing their customers really well. And we'll get into the brand impact in terms of identity, loyalty, and community a bit later. But if we want to understand why this is the case, why are they so good at personalization, it comes down to the fact that when they developed their recommendation systems, Spotify did something really unique and innovative, which was that they moved away from looking at songs in terms of the genre and the artist, and instead they started focusing on the audio fingerprint of the song. So they analyzed how it sounded, the tempo, the beat, and the danceability, and then they made their recommendations. When you listen to traditional current streaming services, if you listen to Sabrina Carpenter, you're probably also going to be recommended a song by Billie Eilish or Taylor Swift because they're all classified as blonde female pop singers. But when you get down to the music of it and how they actually sound, Billie Eilish sounds very different from Taylor Swift. She sounds very different to Sabrina Carpenter. So if I'm listening to a song by Billie Eilish and my streaming service recommends Taylor Swift, I feel a bit of a disconnect. I'm like, oh, this isn't really the music I want to listen to. It's not the vibe. It's not the sound that I want. And it doesn't feel very personal. But when you analyze how the song actually feels, you make recommendations that they actually want to listen to. This was really novel and innovative in the industry. Bodhi's going to share an example of this type of personalization with us because he uses Spotify.
I'm a daily Spotify user, so there's lots of different pieces of the Spotify recommendation system, at least on the user end. Like, it manifests in a lot of different ways. I feel like the best example of this is actually a piece of functionality I use very often, which is called the song radio. So Spotify has this option. Whenever you're listening to a song, you can go to the song's radio, and it's going to generate a playlist for you of songs that meet the same vibe or that have sonic similarities, but that are related to you, so that you are familiar with. So it essentially kind of trawls your songs that you're familiar with, and there's some random exploration component where it's going to add songs that you may not have heard before and compile this playlist for you of songs that all sound similar to this one song you're just listening to. This is a classic example of this more nuanced approach to recommendation in the music services industry that Spotify has taken. It's that audio analysis technique that Maddie is talking about.
So now we've seen that Spotify listens to how a song feels, not just who sings it or the genre. And that's how they drive their hyper-personalization. How could you apply this approach to banking? Well, that is where spend personality comes in. So if you want to actually listen to your customers, you can't simply just listen to their demographics. Spend personality is a behavioral framework that goes beyond traditional demographics and analyzes how individuals actually spend their money. In the same way that Spotify focuses on the tempo and the danceability and the beats of the music, spend personality focuses on the patterns, the rhythm, the energy, and the purpose behind transactions. Unlike demographic segmentation, which assumes preferences based on your age, your income, or your location, spend personality taps into this real-time behavioral data to reveal the why behind spendings. So currently, what we see in banking is that they will assume you want a certain product based on demographic factors like age, income, or location. And that's not particularly effective. The reason being is if we look at the slide now, King Charles and Ozzy Osbourne fall into the same demographic category, but in reality, they probably spend their money very differently. So now if you want to make a product offer or recommendation to people who spend their money differently, one's going to fall short. You need to make a recommendation that actually resonates with your customers. And that's what spend personality does. What we see is you can allow banks to personalize engagement at a deeper level by making the right product offer to the right spend personality. For example, By analyzing the transactional data, you can profile a customer based on whether they are an industrious spender, a experiential spender, or an enthusiastic spender. There's a couple more. And then you can match a product to that customer and move beyond that. You can match the product and recommend that product in a way that actually resonates with them. Just how Spotify can listen to the audio fingerprint of a song, banks can now listen to their customers. And what we see then is that this is the foundation for hyper-personalized financial recommendations. Now, to understand how this works from a technical perspective, Bodhi is going to take us through Spotify's 3-layered approach to their recommendation systems and see how this matches within a banking context. So I'm going to hand over to Bodhi.
Thanks, Maddie. Thanks, guys, for being here. This is a very interesting topic, and it's always nice to draw parallels and fresh ideas from outside the typical space. As Maddie says, and as anyone may know if they're familiar with the structure of Spotify's core algorithmic methods, is that, there's kind of 3 broad categories that any sort of recommendation has to pass through, or that informs any sort of recommendation before it's made to a Spotify user. Collaborative filtering, audio analysis, which we touched on in the beginning, and the use of natural language processing. Collaborative filtering, this is really interesting for us at Ecosystem because it does bear quite a resemblance to kind of the spend personality module, which Maddie was also just talking about. So collaborative filtering is a method by which Spotify understands the relationships between different songs by essentially creating a giant network or graph that maps the co-occurrences in playlists made by users of given songs. This takes a different approach to the audio analysis we're just talking about, or a traditional kind of genre understanding. Let's not consider where the general human consensus is in terms of what genre this music is, and let's not consider what it actually sounds like, but let's consider where it fits with how users arrange music themselves, which is what playlists are. This offers one avenue of understanding, and that's something we'll see emerge in Spotify's technique. They don't commit to one line of recommendation extensively. What they do is they employ several different techniques to get an understanding of the music and how it relates to the user from several perspectives. One broad categorization they do is graphing all the songs with closeness dependent on how often songs occur together. And then that allows you to inform some recommendations. So if someone listens to song X, which has a high closeness with song Y, even though song Y doesn't necessarily fit any of the audio patterns we may expect this user to enjoy, we should consider this as a valid recommendation for that user in some context. So this bears a lot of similarity to what we do with spend personality, specifically in the networked approach, right? Because often in these recommendation systems, there is huge merits to kind of understanding the relationships between all these different elements. In the case of Spotify, that's songs. In the case of spend personality and banking specifically, which is who the spend personality, or the industry that spend personality module was designed for, when we're concerned with kind of transactions, right? So we want to understand customers' transactional behavior. That is the evidence we have of how we should interact with them. We construct a kind of similar graph-based structure in regards to the different transactions that a given customer has made. Then we make some kind of suppositions, some behavioral suppositions in regards to what a transaction of a given type means. So we say spending money on fuel is indicative of some behavioral construct. And those behavioral constructs for us take the forms of the spending personalities. For example, spend on fuel is an indicator that someone is industrious in how they spend their money. It's using a graph-based approach of mapping out and graphing all the transactions we have for a given customer that we can understand, and we can do some computation to determine on a scale of 0 to 1 for each of the personality constructs, how strong in that personality construct a given user is. And then we can perform this at scale for an entire customer base. This enables us to make nuanced recommendations. So even without having to kind of manually look through hundreds, maybe thousands of transactions for a given customer, we can at a glance, and using some maybe even rule-based structure, we can make recommendations based on how they actually spend. And this is kind of the parallel for us in terms of what Spotify does in how they determine propensities for recommending songs based on how people actually use them, right? If we can accept the idea of using a song, and then the analogy of how people actually spend their money with respect to some given institution or bank, right? Madison, is there anything I'm missing in terms of collaborative filtering that we want to mention?
No, I think you've covered all of that. You've specifically looked at the Spotify and then matched how this would work in a bank and specifically with spend personality. I do see that we have a question in the chat. I'm going to turn this one to Jay. Habib asks, in terms of spend personality, what if you have a common account in one bank, so one account used by multiple people? How does spend personality count for that when analyzing transactional behavior? Jay?
Your real world personality and your real world behaviors have got a very different class of analysis compared to what you do in a digital world. I sent you a presentation. Maybe you could load that. I want to show something. Let's say that you're a telco and you have got clients who are multi-SIMmed and you've got 4 or 5 SIMs, and those people interact with various networks over time and they only use you for some of the time. If you're a multi-banked and you only use my bank for some of the time, that personality that I exhibit is quite specific to your digital behavior. Let's say that you use my card or my bank only to spend money on experiential activities. Let's say that you only spend money on my card when you rent movies on Apple or somewhere where it's embedded, or you have it loaded against your Spotify account, or you perform some of those actions, and I see that you never spent money on food. I cannot make an assumption that you're not eating. So all I can make an assumption on when I see that is that you are spending those, with those kind of categories with a competing client. If my core strategy in my bank is that I want to acquire customers who are not spending on certain essential spend categories, what is it worth to me to get them to come to me? So that means even if you are multi-bank that most people are, or you are multi-SIM that most people are, or multi-insured that most people are, the personalities that you exhibit in the context of that particular brand, in that particular type of engagement, is quite unique to that situation. And that means that it gives you more evidence of what you can do later if you want to engage with somebody in different ways. So it's not like you can say that your spend personality or money personality or any of those kind of capabilities is if that's the only way that I'm going to determine who you are. But that is what you look like in the context of what you use me for. So we make that distinction. And the thing about collaborative filtering versus deep learning models and kind of approaches is that, yes, we have got an implementation of that, but at the end of the day, dynamically converged engagements in knowing how you are spending money, because if you think about it, spend personality uses phenomenology and it uses the philosophy of money to describe the core relationships between categories and how you spend money in the real world. That means it's not a data science problem. I think that's the biggest separating factor between looking at it in a banking scenario and a music scenario. In a music scenario, you've got 60 million songs, 580 million active listeners, and mass collaborative matching. In a bank, you've got, let's say, 1,200 or 1,500 categories of spend. You might have 10 million customers, and you want to be able to matchmake those. So your problem that you solve is slightly different, but the analogy definitely is very much in line. So you want to be able to not just use one mechanism, you want to use a multitude of different recommender, including deep learning and real-time convergence models that go beyond what you just do in one setting. The personality per se is your digital representation of who you are.
Jay, should I quickly share that slide that you want to reference?
Yes, please.
Maddie, do you mind?
Go for it. I'll stop presenting.
No, please. We must add as much detail as we can with what time we have.
Yeah, so let's just look at this and that's kind of what you guys did in the introduction, is to talk about the different categories of how the song gets analyzed. And the song gets broken up into transactions. The transaction goes through a Fourier transform, and the Fourier transform converts the analog signal into a digital score. That score then gets put onto a distribution. It gives you separation of the different factors like lyric, pace, tempo, danceability, loudness, and all those kind of properties. And then you dynamically group them long before you do the collaborative filtering. I think maybe that was what I wanted to just fit in here. Long before you get to matching, you train models on understanding how the most important factors are clustered together. You let those important factors emerge using computational social science. Once you've got those to emerge, that sits kind of in the middle of this chart. To the top right of this chart, you then assign a personality that uses archetypal theory. It's a bit of like Carl Jung and social science and philosophical undertones to understand how you would separate people so that you can easily identify them, even if I know little about you. Once you've done that, the bottom right is the most interesting one, and that is to create a taste path. And a taste path is when I want to know how your journey is going to work through the total mass of what I have available to you. In the music world, you've got millions of items that are options. In a typical bank, with all the variations on your current account with an overdraft, your credit card, your vehicle asset finance, your mortgage, and then all of your risk-based products for insurance, if you take a combination of each possible variation that could match to you, the list might be, let's say, 200 in size. So you do have a different quantum. But the part of the story that I think you can learn from a lot is how you create a taste path. The taste path is to say that if I start my journey and I've just applied for a credit card and I see that the person is spending on the credit card buying building products or buying baby products or buying health products, and the categories shift into a certain social system that's in the middle of this chart, the equivalent to a dynamically calculated genre, I can then work out that the taste path, so that means the product graph, needs to then push me to selling you something that is a loan for your home extension, rather than somebody who keeps experimenting and traveling, wanting to get a loan to go on holiday. The idea is that your taste path equivalent in the banking scenario is that how do you find reliable recommendations that is way beyond collaborative filtering? That's got to do with the phenomena of banking and the spend personality, a bit like your story, Bodhi, that spend personality mapped onto your existence, and then finding the guide that I should follow to make sure that I get the customer lifetime value that is right for my business. What is it worth to me to get you to spend more, do more with me than with somebody else? That's why it'll be good to show this as a concept.
We have some more questions in the chat, which I think this one is really interesting because it is something we do want to talk about in another meetup. But we asked it, how would you think about this in the context of loyalty programs and possibly incentivizing people to change behavior, using spend personality to change behavior? For example, if an individual spends a lot on gas, how would you incentivize this person to use public transport? In the case of Spotify, if Spotify was your bank, you would probably get recommendations to use more gas or buy more gas, or you buy gas low, wouldn't it? So if you want to do something different and recommend a different behavior, how would you approach that?
Do you want to try?
Well, I think you're going to have the more comprehensive response, but there are a couple of things I want to touch on. And it's kind of some important points that Vikram has exposed in terms of the core difference between the kind of problem itself. For Spotify, they don't care what song you listen to at all. You know, they want to maximize your time spent listening, but within certain parameters to understand that you have a very healthy relationship with the service, that you, as likely as possible, to pay them again for another month. That's a very unique kind of class of problem. Whereas what Vikram's talking about here is a more complex situation you find yourself as a financial institution, because there are times when you are incentivized to encourage or shift behaviors in a different direction, which is a kind of problem that you don't face in the service world where you're selling a monthly subscription. I just wanted to point that out. I think it can be interesting. The loyalty program fits quite well in the pre-existing structure, in the sense that if you consider all your loyalty incentives as part of the products that you sell, it's relatively easy to integrate it into that existing recommending system. But yeah, I think you must touch on the behavioral change a little bit, Jay, because you have more experience there in regards to the personality drift, etc.
I can maybe give a glimpse and then Eric can jump in as well. I think the big thing that I found is, why would you want to participate in any loyalty system if you are a customer? If you start looking at it from the outside in, you typically want to be rewarded for not looking around. That's what it is. You want to be rewarded for spending consistently and continuously with a product or a service you purchase or consume. If you use a product, what does a loyalty scheme look like? If I'm a car brand and I sell a car that a person typically in their lifespan will buy once or twice. Let's say that you start your career and you buy a small Toyota, and then you make it big, you buy yourself a BMW. You make it bigger, you buy yourself a Bugatti. Now imagine the loyalty program Toyota needs to put in place to compete with Bugatti. It's not going to work. That means in product-based loyalty, the story is different than in service-based loyalty. So in service-based loyalty, think about a bank. A bank transactional system is continuous consumption. If a person takes up a card and they never use it, you mean nothing to them. You cannot measure the importance of a loyalty program in the beginning because they haven't even taken up any of what you have to offer. But let's say the person does open a new account and they engage and immediately start spending, they embed their card on their phone, pay for their Netflix subscription, put it onto their app store, add it to a few places, and they only use you see that they are using many items. The customer probably wants to be rewarded for the fact that you have become their primary, because you can make an assumption in a multi-bank world that people are going to have multiple types of bank accounts. So that means that the loyalty system needs to calculate that if a person spends broad spectrum, so that means essential, non-essential, across many other categories that people spend money on to conduct their lives, and has not shown any drift, so that means they've not stopped spending in certain category where they used to spend with you, that means that your loyalty program probably will have only an impact on saying that this person will continue, hopefully, to spend with me because they're not going to get confused by a competitor. So the personality drift and what the spend will tell you is that if a person switches, let's say they stop spending in certain spaces, you can calculate months before it happened with customers that look like that they are going to stop spending money with you. And in the bank, you got NII and NIR. So you got your net interest income and your non-interest revenue. And your non-interest revenue on your transactional spend is the revenue that the bank makes by somebody actually using you. The net interest income is what you make by selling loans. So that means that I might incentivize you through my loyalty program to either give you cash back or to give you a point of some way or some form that you have to go redeem in some place. And it depends on what the laws and the tax regulation and so on is per country. You're often, like we discussed in previous meetups, there are many factors that make up the total story. But it means that you can reliably and consistently calculate the shift of a person's interest in what you have to offer and map that score onto your loyalty system calibration. So the loyalty system calibration is to say, use me rather than somebody else. You can then calculate over time the impact of you nudging them, rewarding them, giving them feedback on participating, working with you or using you rather than somebody else. And that means that you can then, as you go through over time with any loyalty system, you've got calibrating points. You need to work out, am I giving away too much or too little? Am I giving away to the right person at the right time? Am I getting the response back of incentivizing a person and then getting a negative response back? We've seen that with churn programs. So this means that it's probably a more complex answer, but you got multiple dimensions of how the two can relate. You can use your score to calibrate a lot of your incentives.
Thank you. We have one more question, and I think I'm going to direct this one to Bodhi or Jay. It's about collaborative filtering. So in collaborative filtering with graph data, how do you dynamically adapt the rules for creating nodes and edges to avoid getting locked into a single analytical approach?
I love that.
Maybe I'll give a quick preface or my impression, and then you can get into more detail, Jay. An important thing to note here is we've started talking about collaborative filtering as a starting point, but it is not the be-all, end-all of the recommended system as a whole. In fact, I think it normally just plays the role of so you can develop some closeness score with respect to other songs, and then kind of enrich that feature, and then use that feature in later recommendations you may or may not make. And that it isn't the nexus of your whole recommendation system. It's just another perspective that you can enrich to inform decision making. You would use the collaborative filtering to extract one specific set of scores, and you wouldn't need to dynamically adapt the rules, or you wouldn't have to worry about that to a great extent, because you're not going to make any decisions in that moment in which you discover those relationships. You're going to use it later on. But Jay, maybe you have, that's me speaking from my common sense, not necessarily from experience.
In our product, there is no option to pick collaborative filtering. So it's not like we force the person down that at all. I think that if you implement collaborative filtering as a construct in our product, you just have to configure a lookup against a matrix and off you go. We find that very few or none of our customers actually implement in its own right out of the box. So in network-based, graph-based, offer-based recommenders or deep learning-based recommenders is what we find most customers have gotten to. Collaborative filtering might be used, and it's a bit like what started in places like Amazon. People who bought this, bought that. It's kind of like a non-negative matrix factorization or some mechanism where you assign a score to multiple matching items. But as soon as there's volatility or diversity in the matching mechanism, you find that collaborative filtering is not the best. I think for this talk, it's indicative just to explain it for people who get recommender systems, because in recommender systems, the first thing you learn about filtering mechanisms. And the reality is that in the graph environment, let's take a graph with the network approach. If you train a supervised learning model and want the model to extract the offers that were taken up consistently, you've got a one-hot encoding, you've got a list of all the products that were offered with customers in a data set, and you've got columns to show product A, B, C, D, E, and typically that kind of creates a matrix, almost like a collaborative filter-based matrix. You train the models that are binomials on every single one-hot encoded score. So you can train a model on every pillar, and that then gives you a score in that time frame. Let's say you're a company that sells items fairly frequently. You'll probably train the model daily. Or if you converge very quickly, you could converge it in 1 minute if you got one of our real-time dynamic recommenders. And if you sell mortgages, you might only do it monthly. It depends on the kind of business you are in as to how often you would then go and recreate the scores based on the things that were presented and the things that were taken up. Because that's really what you want to do if you think about any kind of matching mechanism. The challenge is when new items come in, do I explore, or what is the mechanism I will use to bring new recommended items into the list? So let's take a classical example, and then we'll get to the graph answer. I've got a playlist, and let's say I create a playlist with 10 songs, and for the next 2, 3, 4 weeks, I only listen to the 10 songs. In collaborative filtering or many of those algorithms, the model will completely converge around that, and it's stuck. When new items come in, nobody's ever taken it up. Unless you have a very complex or cold start algorithm, it's never going to recommend them. So what do you want to do? You want to be able to take those items, and you then want to have an ability to take the items that were now added. Now, let's say on week 4, you add another 2 songs and then another 1 song. Now, that means that how does the algorithm figure out that the new items that were recommended, this is the one thing that I want to build and then make sure that my friends at Spotify use this. Because it does this dismally, by the way. The one thing it does very dismally is exactly the scenario. As it adds the new items, I want the algorithm to take the time distance traveled, the number of times that the new songs that were added have been presented to me as an option through the randomization engine, so that means through the recommender engine. And then I want the scores to be re-updated, back-propagated. So that means that in collaborative filtering, none of those things apply. None of those capabilities get into the kind of classical ways of doing it. And we've been able to work on solving it in ways that you could pick all the items that are non-popular and run a dynamic experiment on every single time I interact with it that will figure out the items that are added based on a calendar or a time distance, recommend those first. If I see that you definitely don't like them, then only rescore them in the context of the total distribution of what I have as part of the items that I'm supposed to recommend. If you now take something like centralities, if you take a page rank or standard closeness centrality, if you look at that graph in this slide in the middle there of genres, where the closeness is calculated based on the number of incoming links that might have 1 or 2 degrees separation. That means it takes the eigenvector across a particular network tree, is basically score it into the item where the incoming links are coming in from, because it's initially, it's not a dynamic, it's a dynamic network, but initially not seen as a dynamic network, it's seen as a directed graph. As the course gets assigned, you then get items that become important because they got many incoming links. So in our world, we take the page rank is slightly different than just a classical closeness centrality. You take the betweener scores of the items that are not offered often. You take the closeness scores of the things that become very popular, so the node score explodes. Then you calculate the 2 or 3 degrees removed as to which other important item relates to this important item, and reassess the score you give it. So you can add new items consistently. It will keep on recalculating what is important in the network, and it will know that if something is added that is new and not used initially, I first have to test because I haven't collected enough evidence about it being important or not. So the graph will calculate and run those scores in real time every time that something gets offered and accepted. And every time I offer something, those are isolates. So the isolate network has got loose items. The existing network already got scores. And as soon as I present 4 and a person takes up 1, that score creates a link to the item, and it will know that the other 3 gets discounted and the 1 item gets increased in score until the next one comes in. And you can set those parameters of what the closeness score or the eigenvector threshold must be for the model then to convert. So this helps you to deal with diversity and variety and the like. Now, the thing is, in transactional behavior, you have similar traits. So the way that people spend money over time, and as they change their behaviors over time, you want to take into account that the person is now, they only spend on food and now they spend on travel, that you can't now say that the person's personality has shifted entirely. It's drifted maybe for a week, but it doesn't mean you've got enough evidence, because you haven't got the time travel evidence of a person that's going to consistently spend in that category with you. But now you know that they do spend there, and you want to incentivize them to spend it. So the centralities will tell you where those important items lie. If you use a PageRank algorithm, it helps with that. Go to Google and search for PageRank. There's a ton of stuff available. It's basically the way that Google does it.
Thank you, Jay. Bodhi, I'm going to take over presenting because we've got 2 other topics that we want to get through. So we've looked at collaborative filtering, and now the next one, which I find particularly interesting, is the audio analysis.
So yeah, Jay already touched on it in depth, just in regards to doing an analytic on the actual audio file of like some given set of songs, like using a Fourier transform to decompose the sine waves and using scores derived from those constituent waves to determine a numerical understanding for some rule-based or dynamic recommendation that takes place later in the recommendation process. Can use those scores. So yeah, I mean, we already touched on a few of them. I don't have the exhaustive list here with me, but yeah, like danceability, tempo, I think loudness is one, so that you can have a literal numerical understanding of the differences in between each songs with the actual audio fingerprint, and then like use that in your recommendation logic or whatever. That's the audio analysis component.
Thank you. The third and final aspect I'm going to touch on is the natural language processing.
This was really interesting when I found out about this, because I didn't know this took place either. So essentially, Spotify does a bunch of web scraping in regards to mentions of any sort of song or artist in their database. They use some NLP to perform sentiment analysis on all the given dimensions. Then they're going to perform some sort of calculation in regards to tagging the metadata of these different songs with values that have been scraped. So it's when, as we were talking about earlier, you can't take a silver bullet approach to these recommender systems. You need a bunch of different angles, as Jay has also mentioned. This provides an interesting new one that I didn't know about until I was doing research for our chat today. They have some tagging in the song metadata based on the public sentiment around the song. So you can use the audio analysis to understand the actual similarities and differences between songs that have been taken up versus ones that have been rejected to inform the recommendation process. But you can also use general sentiment. So when you see a huge disparity in the audio signature because of, like, for example, one example is like genre fusion. For example, like we may see huge differences in the audio signature between 2 songs because one is fusing with a different genre, and we may not pick that up during our initial analysis or filtering process. During our scraping, we may detect and pick up the sentiment that these 2 songs are related, even though we may not have evidence elsewhere in our recommender system that would tell us that. And we can use that in our logic later on in terms of how we make recommendations. I don't know if Spotify did that. So another interesting aspect. And NLP is a strange one because we do a similar use of sentiment analysis in our own agent management framework, where we use it to detect routing so that when customers are engaging with a given agent using our chat nodes, our agentic framework is designed in a graph-based structure. So there's a specific type of node called the chat node responsible for taking natural language input from a user and then using it to inform specific routing. We also use a similar type of NLP to determine the sentiment of a given user's input, to determine how they get routed, to what recommender they may get routed, etc. So it's funny to see these like new technologies being used in very different ways, but in the same type of system.
Thank you for that. We have another comment from Habib, but it's not a question. I think what he says is really interesting. So using sounds data through ML, it reminds me, we experimented with converting retail transaction to sound. Significant anomalies became audible, making them easier to detect than visual dashboards. So yeah, that's really interesting.
That is so, wow. That is like insane. I would not have even thought of that. So, I mean, Habib, maybe if you want to give us some more information there, that sounds very intriguing. Did you actually use these generated sound files? Did you listen to them to determine points of anomaly? Maybe if you don't want to unmute, you can send us another message.
Can you hear me?
Yes.
Hello. I cannot give too much detail on it, but I can share with you that it was just in a hackathon we did.
Oh, it was in a hackathon.
And
Okay,
we experimented with it because when you do forecasting on a retail data, what happened is it's a lot of data for customer to view and see that which category is performing good and which category is not performing good. And you have to browse through our data, and while you're going to the next level of data, you're forgetting what you have seen before. We convert it into sound so that wherever the sound gives you a problem, you go and see if there is an anomaly or not, and you can easily actually pinpoint to the issues in the data instead of looking into it.
Yes, that's so cool. Hackathons bring out the most creative approaches to these problems. That's why they're so essential. Sounds like fun.
Thank you. That is really interesting. So I think the next aspect that we're going to move on to in this discussion, I see we've got 10 minutes,
So
is
to tell everybody that we have a whole NLP stack that does Big Five scoring, MBTI, name entity recognition, parts of speech. We do sentence encodings, we do similarity, we do toxicity. And it's essentially a stack that is created to do those kind of NLP functions. But the question could be, why not just do it in a language model? The biggest reason is that you want the reliability and the consistency of the score to be consistent. And as soon as you want something to be highly consistent, especially on different kinds of input, you will typically use an old NLP approach rather than a generative model approach to do any of those actions for you. I'm really interested in that transaction data into sound. We often, and we've got a module called emotion genetics, where we take what people say and how they discuss things on call centers and extract the emotional state and everything else from the sound. So yeah, that is very, very interesting.
Thanks.
Thank you, Jay. So we've looked at the technology behind all of this and their graphs and collaborative filtering. It's pretty clear that Spotify was really innovative and transformed music streaming with their recommendation systems and how they drove this insane amount of hyper-personalization. I know that the actual business impact of what they've done extends far beyond just making really good music recommendations or making personalized playlists. I wanted to kind of look at some of the business impact that they've had and that their personalization has had for them. One topic that I know is true is their brand loyalty. I'm not sure who here uses Spotify or Apple Music. I know Rob said he uses YouTube, but I myself am an Apple Music user, purely because it's what my family signed up for and it's convenient. And when I said that today, before this meeting, there was kind of this shock and disbelief that I use Apple Music and I don't use Spotify, almost as though people kind of, I don't want to say judge, but they're questioning my life choices. My life's like I've made a poor lifestyle choice. You don't use Spotify? What, why? On that, we can see that Spotify users are incredibly loyal. The few in this meeting are diehard fans. But while I was also doing my research for this meetup, what we've seen is that Spotify outperforms Apple Music in terms of brand loyalty. And Spotify users are more likely to recommend their service. They're also more likely to maintain or even increase their usage compared to an Apple Music user. So if we make that connection to banking, where you can, number one, make the right product offer to your customer in a way that resonates with them, we know that they're going to be more loyal. They're more likely to engage. They're more likely to recommend your service and engage with you as a bank. Every bank wants to be the bank that when someone says, oh, I don't bank with so-and-so, someone goes, oh, why? So that's the first element of brand loyalty. The second aspect that I want to talk about is creating a community beyond just their streaming services. Every December, Spotify releases Spotify Wrapped. What I've seen is that millions of people get together and share their personal listening habits. And it almost becomes a part of their identity. It says something about you socially that you can be quite proud of. When I was asking Jess about Spotify Wrapped and she shared her family's Wrapped, her sister is really proud of her Spotify Wrapped. So why this is so important and effective is that people come to Spotify for streaming, but they engage with the company beyond that service, discussions online, And what they do is they drive this engagement where their customers and their listeners keep coming back to the company. And the example that I think of in financial services, which Matt Hindley, our partner, always talks about, is this watering hole in financial services, where whether it be banking or insurance, you want your customers to keep coming back to you and you want them to engage with you beyond just what you offer. So for example, in insurance, a big problem is that your customers only engage with you when you make a claim. In that instance, it's not particularly positive. I mean, something's happened, now you have to make a claim with your insurance. So if you can create this space in this community where your customers keep coming back to you, whether it's via your app for loyalty and rewards or they engage with you, you want to build a personal relationship with your customers. And Bodhi, as a Spotify user, has a great example of how Spotify keeps people coming back to their app. So if you can share that with us.
Well, yeah, it's nice for me to inject my little anecdotes here in regards to how I use Spotify, but they have another feature called the day list, right? And this is probably my favorite thing they offer. And every day they'll create a curated playlist for you with some kind of pre-assigned theme. It's not a whole bunch of fresh music, because that, like, I don't know, I struggle with them there. They can't recommend me new music properly. But in terms of how to order and pick and curate what music to listen to in a given day from music they know I like, the day list really does it for me. So that's another example. And just the format in which they introduce it in like the UI and everything makes it really easy. It feels very easy and natural to wake up in the morning and check what's on the day list, which I think links back to what Maddie was talking about, where there's like a kind of almost unspoken or not as talked about aspect to any sophisticated recommender system, which is delivering on the recommendation, right? So it's one thing, yes, you're going to have to do a lot of engineering and maths and stuff in the back end to like determine what product is like going to be the optimal given some data set, right? But it's another thing to deliver the invitation to interact with this product. We have experimented quite a lot with recommenders configured to choose how to offer a product to a customer and dynamically learn on what is the most effective way to offer the product beyond the calculation and everything and the ML going on in the back end in terms of what is actually the most effective product. One of those unspoken aspects.
That actually leads exactly into the next point that I want to discuss, which is what you've just said. Sometimes, it's one thing to have the recommendation and know which product to recommend to your customer, but it's another to communicate that in a way that really resonates with them. With spend personality, what we've seen is that different spend personalities like to be communicated with in certain ways. You may make the same product recommendation, but if it's to an industrious spender, you want to focus on a specific element in your messaging compared to an experiential spender. So making the recommendation in a way that really resonates with your customer is just as important as having the recommendation itself. And the example that I can think of in banking and both the music streaming service is at the beginning of the year when the ecosystem.AI team got together, we had someone talk to us about banking. He told us why he is with a specific bank. He said it wasn't because their products were particularly fabulous. They were not the most competitive. They certainly weren't the best, whether it was a credit card, debit card, trust, whatever it may be. They weren't particularly the best products. But when it came to engaging with him as a customer, they were incredibly personalized. They knew who he was. If he had an issue and he came to the bank, they knew who he was, what products he had, what services he had, how long he had been with the bank, all of that. And it really sold him as to why he should be with this bank and stay with this bank, because they were incredibly personalized. And the example that I think of now with music streaming, when I was doing my research, was that in terms of audio quality, Spotify is not the best. Apple Music outranks Spotify. But more than that, all other streaming services, I can't even name them, outrank Spotify in terms of audio quality. But Spotify is still one of the top dogs when it comes to music streaming. They are considered one of the best with incredibly loyal customers. So you don't necessarily have to have the most competitive product. If you can drive hyper-personalization, really know your customers and engage with them in a way that resonates with them, you can outrank all your competitors. So beyond that, when it comes to your customer, you reduce churn, you can increase your ability to upsell and cross-sell, you know which offers to make them and how to make them in a way that resonates with them, and you extract more from them from a customer lifetime value perspective. And to do this at scale, you do this with spend personality. In the same way that Spotify already had all of their customers' listening data, their listening habits, their artists, their genres of choice, they just saw the person behind that. And you can do exactly the same with spend personality by seeing the person behind the transactional data. So that's ecosystem.AI and Spotify wrapped. If we have any other questions or comments, please feel free. I see we do have a little bit of time.
Mary, can I try something on?
Yes.
I like your analogy around the sound quality. If you know that your customer is unlikely to have a world-class Bose or some really well-designed sound system where they'll be able to listen to the sound quality difference between 160 kilohertz or 192 kilohertz difference in quality by the time the sound gets delivered, and making an assumption that their ears don't have, some kind of condition where they might not hear everything, and making an assumption that they're all in clean rooms that are completely soundproof, and making an assumption that they never listen to music on tiny music devices, phones, in the car while they're driving when there's wind noise, then yes, that means that the analogy with a bank, they focus on 100% the wrong measures to deliver the correct outcomes. We've got 100 examples of banks sending you letters. An example with not paying your card on time. I did it deliberately to see what happens. I've had this card for a year. Nobody emailed me, contacted me, discussed anything with me, forgotten that I existed. Then I missed it. A week later, I got 5 texts, 6 phone calls, emails, a WhatsApp message. I speak to an agent, and all of a sudden I was very important because they wanted to collect a tiny amount. Then I figured that if I can get 10 times what I need to pay, then it's worth it. So I keep the agent on the call long enough and all that. And yet, by the time the bank reports on its results, it's probably going to say, oh, check, phone calls was the most successful in collecting money. Instead of saying that, why don't I just take all of that and convince this customer to spend every month, and I used to spend on that particular bank card a huge amount on travel. I used to use them for travel all the time. When I stopped traveling, nobody noticed until I didn't pay 26 Rand 50 that I used to spend disproportionately more than that every single month. And that's the thing. That's why I think that if you then take the engagement, the sound quality, the fact that I know that you exist, I love that part of your story, by the way. So I think that's why it resonates.
Thank you so much for joining, everyone.